Thomas!
Oh, hello, Marcin.
Hello, what are you doing?
I'm going to refuel LPG to that car.
But this is a diesel engine.
So what?
It is a diesel engine. Oh, okay. Can we see it in the workshop?
Sure, if you want.
Let's go.
Okay. Hello, Marcin. How are you today?
Hello, Thomas. I'm fine. What about today's topic?
Yes, today's topic. Here you have this Honda Accord that we have refueled few minutes ago. The diesel engine, but with gas installation, right? With the gas installation.
See what you have here.
Yes, in this car we have the LPG installation.
Oh yes.
But
you have injectors.
Yes, you have injectors here.
Reducer,
there you
ECU.
have ECU, the electro well.
Why?
This is filter.
Thomas, why?
Why? Well, the first thing, a very important thing that you should know is that savings. Once again, savings. Yes.
Okay.
With the gas installation, this engine should consume less diesel,
fuel.
right?
Okay.
In some percentage, you can inject gas. Yes. So you can take off some diesel from the engine, and you can put gas to the combustion chamber. Okay.
So as I heard something about this, let's follow the rules. Why?
Okay.
And how?
Let's check it.
So this is the scheme of an engine. Typical four-cylinder engine, and the main rules and the main informations in relation to STAG Diesel. It is that the diesel engine works on not like a petrol engine on stoichiometric mixture, but it works on very lean mixture. So we have a lot of oxygen in manifold, so we can use this oxygen to burn it with the gas. It depends, so it can be LPG or CNG.
Right.
And then, because of we mixed with the air these gases together. Of course, they are not together. There is no plant, but we can mix one of them. I mean LPG, for example,
CNG,
or
right?
CNG, but not together.
Right.
This is our next project: mixed two gases, LPG and CNG, and put it in and see what will happen. And I'm not sure what will be the end result. So it will be a challenge for the next project.
From physical point of view, it is possible, right? But okay, you need to have two controllers,
today
tanks, but
we are using one fuel.
Okay,
let's focus on one fuel.
But very important thing is that for the STAG Diesel solution, it's not important that you have LPG or you have CNG, right? The STAG Diesel is working with one or other type of the fuel, gas.
And because of we have, of course, the dosage of an air in the inlet manifold, so to control the proper mixture, the proper combustion process in the cylinder, we need to measure the output level of the oxygen. That's why we have a lambda system, and we need to mount this lambda system in the exhaust pipe. So we have a exhaust manifold, and then we should install the lambda sensor and give this information about oxygen level. Yes, what's the percentage of the oxygen level in the exhaust gases, to be sure about the algorithm works about the proper mixture in cylinder. So this information goes to STAG Diesel ECU.
Right. Because when we are starting to inject gas to the manifold, we have the mixture, the gas of the and the oxygen. As Marcin told you, we use that oxygen to burn gas, LPG or CNG. So we need to have information, control the amount of oxygen, because if we do not have any oxygen, we cannot have the combustion.
Yes, the efficiency of the process in the combustion chamber is out of the limits. Yes, that's why the oxygen level should be on proper dosage. Usually is the minimum 3%, but these details in relation to more detailed information will be in the next our presentation in more technical stages. At this stage, the next very important information for STAG Diesel is to control the level of knocking. And why we do this? Because during mixing the air in a manifold, the air is going inside the combustion chamber, and because of sometimes there is a situation when the mixture is not homogeneous. Yes, there is some stratified areas in the cylinder, and these stratified areas are occurring uncontrolled starting flame in the cylinder, and this can occur high pressure and occur knock, and of course the knock is a source of engine damage. It can burn some components, destroy the piston or valve or even a head, and sometimes cylinder, even a cylinder can crack during high level of the knocking. That's why we need to add additional one sensor, is a knock sensor, and so we have one, then we'll have another, it means a second signal from the knock sensor, and knock sensor should be installed on the engine block. The next control information is about the temperature of the exhaust gases. So we need to install another one sensor, let's call EGT, exhaust gas temperature sensor. So altogether we'll have three crucial signals for control algorithm of the STAG Diesel ECU.
Yes,
so we have three very important signals.
It's not only for the proper adjusting or setting the systems, but also for the safety reasons of the engine, right? So that's why we need to get those three signals from additional sensors. This is the main difference between petrol installation. That in the petrol installation you don't need to install those sensors. In the diesel system, we necessary to have that information for the safety. And
so again, oxygen, lambda, because of efficiency.
Yes, more gas, less oxygen.
Efficiency, then knock value.
Yes, more gas.
Safety protection. It's a safety protection about situation about inside the engine.
Yes, more gas, higher value of the knock.
And EGT, so we need to control temperature of the exhaust to protect turbocharger, to protect accessories like DPF, filter or STR catalyst system, or typical catalysts. Yes, that's why we need to control it to protect other components. Of course, the exhaust valve, because during the adding the gas, the situation when engine strategy, diesel ECU strategy, during cleaning the DPF, ECU is rising the diesel dosage, or it's spraying on Opel exhaust valve additional fuel dosage, and is rising the temperature of the exhaust gases. That's why we need to control it to be sure about efficiency and thermal protection. That's why we should have these sensors. And without these sensors, of course, it's possible to add the gas, but there will be no such a good efficiency of the fuel consumption, because we can, or of course, there can be limitations of safety of the engine. Yes, for sure.
That's right. Marcin, one question. We can install STAG Diesel system only in new engines, or maybe older one?
I don't know, you can tell me. Okay, John. So, of course, the STAG Diesel ECU is prepared to work well in every kind of engine, no matter it is a mechanical old system with the section pumps or mechanical injectors, or it's a common rail like the newer one and newer construction, or also in the pump injectors. So every kind of the engine is prepared to work with the STAG Diesel. Just you need to focus on choose proper accessories in the set of the STAG Diesel. So in situation when there is a mechanical engine without the crankshaft position sensor, so we can add the crankshaft position sensor to the engine and then use the signal to control the engine speed.
Yes, because the engine speed, the RPM,
crucial,
the values are necessary to.
Yes, it's crucial to work.
Exactly.
Exactly. Right? Then, because of the old system cannot have, for an example, the throttle position sensor.
Right.
So you can add the throttle position to the system, and STAG Diesel can use the external or integrated or just from the kit. So you need to order proper kit.
That's right.
In kind of you need to focus what kind of engine it is. Then if we switch to the common rail of course is included with the throttle position default. The default in the engine, there is
the engine has already position, all
there
the
is
sensors.
A crankshaft position sensor. So, but in this area we can have better efficiency on these engines because of what?
Because that's right. Because when we are talking about the common rail engine, it's obvious that the common rail engine, they have common rail,
the fuel rail.
Fuel rail with the injectors. And what is very important for the STAG Diesel solution, that common rail has the sensor, right? Sensor that is measuring the pressure of the fuel, the pressure of the diesel that is in this rail. So if we have the fuel pressure sensor, we can read the pressure. We can read the pressure just like
this information goes
to diesel, right?
Diesel ECU, yes.
Yes, diesel ECU is reading pressure from the fuel pressure sensor, and our controller, we can use connections that we have in our controller to connect to the signal from the fuel pressure sensor.
We are cutting the wire,
yes,
and informing the STAG Diesel about, and then we emulate the signal.
The signal, yes. And the advantage of this type of a connection for the final customer is that using the STAG Diesel and the application, we can decrease the pressure. Let's say not physically, okay, but we are sending the
action of emulation is that the diesel ECU reduce the pressure.
Reduce the pressure in the rail. What the conclusion is that if we have the less pressure of the diesel, yes. So
of course, the end result is that the dosage of the diesel is lower.
Lower. That's right. That's right. So we have savings in the
diesel consumption. Yes,
that's right, in the diesel consumption. This is the one of the sensor that we can connect. The second one?
Second one, we have throttle position sensor.
Right.
And this signal also is going to the diesel ECU because there is no area, so I will pass out and do it like this. Yes, and this information is also necessary to choose comparing to the load of the car, of the engine. The diesel ECU is deciding about the diesel dosage.
Right, right. And so if we are talking about those two sensors, TPS sensor and the fuel pressure sensor, it is important to know that our STAG Diesel controller is working, can work with the engines engines with two pressure sensors, or TPS with two channels, right? Yes, so if you have engine, for example, V engine or 8 engine, that engines have two fuel pressure sensor, you can emulate both of them using STAG Diesel sensor.
Just parallel in the system. Yes,
that's right. And the same situation with the TPS, right? So you can emulate also TPS with two channels,
yes,
right?
With two channels. No matter it's rising up or falling down, depending on the characteristics. we can use STAG Diesel to emulate both type of the signals. Yes.
Yes, that's
rising
important. An important
dropping.
thing is that both of them should have the rising,
The same characteristics. Yeah.
falling.
Should be,
Yes,
yeah.
characteristics.
Falling
right.
or rising up.
Okay,
that's
Marcin,
the step.
maybe it's very important to show where we can install the gas injectors, right, in the diesel engine, because I think
Okay,
we didn't
where?
mention of this.
Okay, of course, we will show you guys. But the first, it's after choosing the proper kit, depend of the kind of the engine, mechanical, common, we should to know also what other components we should choose, like type of the controller, because we have
right.
STAG 4, Diesel 4, STAG Diesel 6, and STAG Diesel 8.
Yes.
And
What does it mean, 4, 6, 8?
Nothing.
4 cylinder,
Okay,
6
there is
cylinder,
no
8
relation
cylinder?
between the number of STAG Diesel 4. It's not dedicated to work on engine with the 4 cylinders.
Right.
So
That's
even
right.
there is a 4, yes, in the name of ECU,
On
it
the
doesn't mean
sticker,
that
right.
there is a dedicated for the 4 cylinder.
cylinders.
If there is a 6 or 8, it's the same. There is no relation with the number of the cylinders. Because of this is information how many channels of injectors we can handle it.
Right. How many?
Anyway,
yes.
okay.
How many injectors we can connect to the
Yes,
system?
exactly. And why?
Why?
Because of there is a main difference between petrol ECU, petrol conversion system, and the STAG Diesel that we need to deliver to the diesel engine. It will be a 500 horsepower engine. We need to deliver enough fuel in cofactor of energy. It means that we need to deliver 50% of engine power.
Right.
In this case, if the engine will be 500 horsepower,
Right.
we need to deliver 250. What does it mean for us? We need to handle 4 injectors or 6 injectors or 8 injectors to be enough good flow to handle it 250.
That's right.
If we choose 4-cylinder STAG Diesel, in this case, we should have around 70 horsepower per injector, or this will be 120,
lower.
67. Okay, 67 per one injector. It's too high because it will be on the limit.
On the limit
What
of
does
the
it
work
mean?
injector, right?
We should use, in this case, 250, we should use STAG Diesel 6
Right.
and choose 6 injectors with enough flow to handle 250 horsepower.
Yes.
That's why the main reason of choosing the diesel ECU and kind of which one to choose, it depends on engine power, nothing more. There is no relation between cylinders of an engine.
Yes. So in this example, you can have 500 engine, 8-cylinder engine, diesel engine, but you need to use STAG Diesel 6,
Yes.
right? That can operate only 6 injectors,
So
not
again,
8.
The
but
engine
6.
power is the factor that we are choosing the proper controller.
Yes. So
And then
Marcin,
we can switch
yes.
to your answer 2 minutes ago.
That's right. That's right.
Where,
because
where to put the nozzles.
that's right. Because if you have 8-cylinder engine and you want to use 6 gas injectors,
Exactly.
where to put? On this cylinder,
I don't know.
this
Maybe
not?
the PF output.
maybe,
of course.
maybe,
So
maybe. So-
because as we told about the
Mixture
stratified and homogenic mixture in the cylinder.
Mixture. Yes.
Mixture in
Mixture.
the cylinder.
This is important. Mixture.
Yes. So we need to prevent it. This situation. How to prevent it? We need to occur better mixing, and to have better mixing, we need to have time and space to mix proper the air with the gas. To handle it,
Time and
we need
space.
to
Just like
extend, yes,
Star
time and
Trek,
space, like a Star Trek situation, to prevent going the speed of the light.
right.
What we should do? We should expand this trail, what's
Right.
called trail. So the trail should be as long as possible, and usually in the construction on the engine with the turbocharger, when the fresh air goes to the turbocharger, then heated by turbocharger air goes to intercooler.
Right.
So the I think the most effective place to put it, the nozzles is
just place, right.
just before the intercooler. So we are putting the nozzles around this area.
Yes, that's right. So in this situation, we have enough time to mix air with gas, right?
And there is a much more higher probability than we have here. The mixture will be homogenic. Yes,
right.
There will be no stratified situations when they occur. Knocking in the cylinder.
Yes.
This is the limitation. If knocking is occurring, we need to reduce the gas doses. And then, of course, the end efficiency is going lower. Yes. So to prevent it, we need to have enough long trip of the gas together with the air to mix it properly.
So that's right. So if you install injectors far away from the admission, you will have less knocking, right?
Exactly.
Less value of the NOx. That's right. That's right.
So we have the power factor. We have the place to put it to prevent the knocking, to protect the DPF and STR systems against this. And the next thing, what we can tell about this?
So, Marcin, just only to
the factor of
mention
the factor of efficiency. We told you, yes. There is another factor in many countries. There is a situation today when the cities of the bigger cities, they have not allowed to drive the diesel without emission like Euro 5 or 6 cars in the city center. And the rules about this is there is a extinctions. Then when the diesel is running with CNG or LPG, there is a rule that with these systems, even the diesel is Euro 4 can go in this restricted area.
That's because it's more friendly.
Yes, and the reason is that because we are adding the gas to the engine, the efficiency of combustion process in the cylinder is just way better, and we are not generating such of NOx emission, such of carbon particles, and so we are having a little bit better efficiency on DPF. We have lower NOx. And CO sometimes, yes, it also depends on engine construction. So overall, the emissions is better. That's why it's allowed to drive these cars in the city centers with the restrictions.
Yes,
this is the reason.
That's right. So this is the second advantage, right? We just started with the information about the savings. Right?
Yeah, so we have a less even 50% lower diesel reduction. Yes, so we were reducing the diesel usage. Then emissions,
right? And this third thing is that we can use the amount of the energy, the power and the torque of the engine during driving.
Exactly,
right?
Because there is a straight relation between the gas dosage and the output power and the torque of the engine. So even the typical feelings of the driver is that engine is more elastic in driving conditions, no matter it is. But in the low and the middle load of the engine, with the driver is feeling that it just easable. The engine is revving is quite pleasant to drive. Let's call it.
That's right. So in general, we can say that the STAG Diesel installation is very flexible. Why it's flexible? Because one part of the customers they are looking for savings, economy. The second part, savings not so important, but environment. Yes, the friendliness of the environment.
Is environment friendly. This is the factor.
And the third one, just for raising the power and the torque of the engine to make.
And the main market, comparing to the third factor, is like agricultural machines.
Right.
Yes, when the lower power tractor can drive with machines with, for an example, it can handle 2 or 3 tons maximum. because it's output power, it's the limitation. But with the CNG or LPG system, the output power is 20 or sometimes 30% higher.
Right.
Automatically, the limitation of the machines that can be used with the tractor, automatically they are can be bigger. Yes. So in this same time of a walk, it can walk with a bigger area. Yes. In agricultural systems, this is a demand, the bigger power.
Right.
Yes.
So Marcin, as you told us that we can install system in the old mechanical engine, pump injector solution, or common race solution for 6-8 cylinders. That means that our STAG Diesel can be installed not only in a passenger car, right?
Of course.
Not in the trucks, not a tractor, but
it can be used in tractors, power generators, boats, and even in the tank.
In the tank, right.
So you can choose our YouTube profile, then you can put it in search place and try to find Merida engine tank. Yes, tank, it's a tank with close to 2,000 horsepower. Then, of course, this is a marketing. There is no army driving around with diesel and CNG and or LPG.
Right.
It's just a marketing stuff that we made a big tank with a LPG system, so you can see how it's driving. That's
right.
Yes, that's right. That's a nice thing to see.
Yes, yes. So we have, I think we have.
So at this stage, yes,
right?
At this stage, we want to invite you to the next webinar. Yes, and the next webinar topic will be more technical aspects of the diesel, how it will be mounted,
physical installation,
yes, the details about installation. So you can find these details on the next.
That's right. Webinar. But we also would like to also tell you to write the comments on the under our YouTube movie. Let's say.
If you have also some questions, we will try as soon as possible give you answers in relation to today's webinar. Of course, yes. Use the Facebook profile of AC Gas Company. And do not hesitate to write an email, of course, stack at stack.pl. This is our email address that you can write to us. And it was very nice to meet you today at this webinar.
That's right. Thank you very much, and subscribe also our channel on YouTube.
Thank you.
Thank you.
Bye.
Bye.